Good morning, Mr. Fry's compound probability quiz here I'm going over for his geometry class. So it says to answer the following questions in complete sentences. I'm going to read this to you, give you as much clarification as I can. This is a quiz, so I want you to be as independent as possible also. So here we go. Number one, what does it mean when two events are independent from each other? 2, what does it mean when two events are dependent on each other? And then 3, describe the difference between the independent and dependent probability formulas that were used in this section. So I would use your notes on these and make sure that you're thinking of this phrase that I wrote here is going to be very important as you're thinking of differentiating between independent and dependent and talking about the formula. Does the first event affect the second event? Okay, so one of these, the first event doesn't affect the second event, so you still have, like the same amount, the same probability. The other one, you're going to have where the first event does affect the second event, where you might not be, you might not have as many selections in the next event because the first event had occurred already. So that's going to be another one. Hopefully that helps in differentiating those in 1 through 3. For the next section, for the following problems, find the probability of each event occurring and also explain why the events are independent or dependent and show all necessary steps and work. So for number 4, if you have 3 quarters, 5 dimes, and 2 nickels in your pocket, what is the probability you will pick a nickel and then a dime without putting the nickel back in your pocket? So to start off, there are 10 possible coins that are choosing from, and this is not taking in consideration that you could feel them and understand what they are. Maybe you're picking them without your fingers or something. I don't know, because who can't feel the difference between a quarter and a dime and a nickel? But without considering that, so you're picking from 10. So you're going to go nickel. So look at your nickels and look at how many possibilities. So use those 2 numbers. And then you don't put that nickel back in. So now you're working with, instead of 10 coins, now you're working with 9, and then picking out a dime. And then so dimes, you're going to use this number and this number. And then you're going to do your whole probability thing, multiply them out. And get the fraction, see if you can reduce the fraction, and get a percentage out of that. For number 5, I don't think you have to get a percentage, but I don't know. You look at his directions. I'm not sure if it says he wants a percentage or not, but you can go ahead and do it. Number 5, when rolling a die, that's 6 sides, and flipping a coin, that's 2 sides, what is the probability of at least getting a 3? So at least a 3. So we're talking about 3, 4, 5, and 6. So that's 4 numbers out of the 6. Okay, and then a tails. Multiply that by just flipping a coin, a tails. So that's 1 out of 2. Multiply those 2 together and do your thing. Number 6, a deck of playing cards contains 52 cards. What is the probability of pulling out a king of diamonds? So that's 1 specific card out of the 52. And without replacing it, so now you have 51, an ace of spades. So that would be 1 specific card out of the 51. Multiply those 2 fractions together, and you got yourself an answer there. Reduce the fraction, put it into a percentage, and you should be good. Putting it in percentages, once again, I don't think so. Listen for him specifically to give directions on that, but if you can, just go ahead and do that. Just divide that fraction, move the decimal over, and make it a percentage. So wouldn't hurt. Good luck.